So now we're going to take a look at the non-calculator, or excuse me, the calculator part of this test. So it starts on that second page. And I don't think I'm actually going to type everything into the calculator here. Hopefully you'll be all right with that. So when we're solving here, we can switch this into a log. So this would be log base 5 of 15 equals x. And when you type that into the calculator, you should get 1.68. So this next one we have to do a little solving first. Plus 1. So 2 times 4 to the x equals 14. Divide by 2. So 4 to the x equals 7. So rewriting it as a log, log base 4 of 7 equals x. And you should get around 1.4. The next one here, let's see, if we rewrote it as a log, log base 3 of 12 equals x plus 1 minus 1. So log base 3 of 12 minus 1 equals x. And just remember, only the 12 part is in parentheses when you're typing it into the calculator. And we should get 1.26. This next one, if we rewrite it as a log, log base e of 1.72 equals x. Well, log base e is the natural log of 1.72, and we end up with 0.54. So this next one, before we switch it to a log, we need to divide by 3 first. So e to the 2x plus 2 equals 27. So we have log base e of 27 equals 2x plus 2. So we have the natural log of 27 equals 2x plus 2. And now we solve for x. Subtract 2 equals 2x, and then we divide by 2. And this is another one, make sure that just that 27 is in parentheses. So let's see this next one. We add 7. So that would be negative 8. Divide by negative 2. E to the 6x plus 2 equals 4. And now we'll change it to a log. So we have log base e of 4 equals 6x plus 2. Well, we know log base e is the natural log of 4. And if we solve this one, we subtract 2 and divide by 6, so we'd have the ln of 4 minus 2, and the entire thing divided by 6, and we should get negative 1.02. Now this last one here, these are probably the trickiest when we have x's on both sides. This is where we said log, and we log base 10, so we don't have to write that 10 in there, just that common log, equals the log 7 to the 5 minus 3x. We like this because now our exponents can come out in front. So x minus 4, log 6, 5 minus 3x, log of 7. And if we distribute, so we have x log 6 minus 4 log 6 equals 5 log 7 minus 3x log 7. So now we have to get our x's on one side, so plus, and you can move either one. And then the non-x's on the other, so plus log 6 plus 4 log 6. So we have x log 6 plus 3x log 7, 5 log 7 plus 4 log 6. Factor out an x. So 5 log 7 minus 4 log 6. And then we divide by log 6 plus 3 log 7. Log 6 plus 3 log 7. And if we type this into our calculator, we should get that x is 2.21. Now onto this back page, the word problems here. Jose takes medication. After T minutes, the concentration of medication left in his bloodstream is given by this equation. Write down A of 0. Okay, well 10 times 0.5 is pretty easy, Mon. 0.014 times 0. Well, let's see, 0.5 to the 0 is 1, times 10 is 10. And then after 50 minutes, well, all we have to do is plug in 50. So 10 times 0.5 to the power of 0.014 times 50. And we should get 6.156. Now let's take a look at this next problem here. At 1 p.m., when there is no medication left in his bloodstream, he takes his first dose of medicine. He can take his medication again when the concentration of medicine is 0.395 milligrams per liter. When will he take his meds again? So we want to know time. So 0.395, 10 times 0.5, 0.014 t. So we have to solve this. So first thing would be to divide by 10. So we have 0.0395, 0.5 to the power of 0.014 t. Change it to a log. So log base 0.5 of 0.0395, lots of decimals here, equals 0.014 t. And then we divide all of this. So we end up with t equals 333. So that would be minutes, but we have to answer this question. So at what time? Well, if we divide this by 60 minutes, we end up with 5 hours and 33 minutes. So if we look at the time, that would be 6:33. He can take his medicine. Oops, going the wrong way. So this next one here, a city is concerned about pollution and decides to look at the number of people using taxis. At the end of a year, I'm guessing that's supposed to be 2000 right here, there were 280 taxis in the city. After n years, the number of people who use taxis is given by this. Find the value at 2005. Well, that's at 5 years. So 280 times 1.12 to the 5th. Well, that's about 493 taxis. After 7 years, will it double? Well, let's see. Will it double after 7? 280 times 1.12 to the 7th is 618. Well, yes, it definitely doubled. And then this bottom one here. Misusing is saving money. She invests, it has 2.5% compounded continuously. How much interest after 10 years? Well, continuous is that one with the E. So 0.025 times 10. If we type that in, we get $7,704.15. So how much interest? She's earned $1,704.15. That's a pretty good deal. How many years until it doubles? Well, if it doubles, if she starts with 6,000, she'd have 12,000. 6,000 e to the 0.025 times t. Divide by 6,000. So we have 2 equals e to the 0.025 t. Switch it to a log. So we have log base e of 2, 0.025 t. Again, log base e is the natural log of 2. And then we divide by 0.025. And we end up 27.73. So it would be take 28 years.